So now let's put position, velocity, and speed together. The rate is the velocity. It's position change versus time change. Velocity can be positive or negative. Positive, we're going in a positive direction. Negative, we're going in a negative direction. And velocity is 0 when we stop. And there will be a horizontal tangent line on the position function. So let's take a look at these two graphs, position and velocity. So here in red, in the first graph, we have the position function. Notice in red here, we're moving in a positive direction. If we look at the velocity function, that corresponds with this right here. Right? So when we are above the x-axis, so when velocity is above the x-axis, the particle, whatever, is moving in a positive direction. Notice here we have a horizontal tangent line. That indicates, let's just call it a particle for now. That indicates the particle has stopped. Notice a horizontal tangent line on the position function equals an x-intercept on the velocity function. And I do believe this is in your notes. It may be all filled in. All right, and then here you see where the graph, the position function is in blue. We are moving in a negative direction. Right? So notice that if the particle is moving in a negative direction, the velocity is below the x-axis. Right? So negative direction, which means our position function has negative slope, means our velocity function is below the x-axis. So when the y values for velocity are negative, the position is going in a negative direction. Notice here we have a horizontal tangent line there at t equals, it looks like maybe, let's see, 6, it looks like, I say I'm going to read it, 2, 3, 4, 5, 6, 7, looks like 8. So at t equals 8 seconds there, we have a horizontal tangent line. Notice that horizontal tangent line corresponds with an x-intercept on the velocity function. So right here we are stopped. The velocity is 0. So the y values for the velocity function is just the velocity. Right? And so if velocity is 0, right, if we're on the x-axis, if our y value is 0 for velocity, then we are stopped because our velocity is 0. Right? And then notice after we stop, we turn around. So every time this function is stopped, it's turned around. That's why it's stopping. It's turning around. Now it's moving in a positive direction. Let me make that nicer. And notice that when the particle is moving in a positive direction, when position has a positive slope, the velocity function is above the x-axis. All right, so we're a positive direction when velocity is positive. When's velocity positive? When it's above the x-axis. We're moving in a negative direction when velocity is negative. When's velocity negative? We're below the x-axis. And we're stopped when the position function has a horizontal tangent, which corresponds to an x-intercept for the velocity function. Now notice I said position, velocity, and speed. So I'm going to graph the speed function in purple. And well, the speed function is going to look just like the velocity function, except in one location. So it looks like velocity here is -4. Instead of being -4, it's going to be +4. So if you just flip up that section of the velocity curve that is below the x-axis, you would have speed. So speed here is, I'll just kind of graph it next to it in purple just so you can see both things. All right, so technically it's overlapping, but this would be speed. And speed is the absolute value of velocity. All right? I had my graphs color-coded to match the position function, so oops, I didn't want to totally cover over it, but I'd like to be a little closer. I don't think I can get it to move. Well, hopefully you get the idea. Maybe if I, oh, heck, maybe if I fill in the space over here. There we go. Now you'll just think I'm a sloppy drawer. All right, so now that we've looked at position, velocity, and speed, in the next Nearpod, we will look at acceleration. All right, so thanks for watching, and bye for now.